Hello everyone, my name is Haris, and in this video we're going to be going through a rather infamous LeetCode problem, namely LeetCode number 1, choose_sum. So for this problem, we're given an array of integers called nums and an integer called targets. We want to return indices of the two numbers such that they add up to targets. We can assume each input has exactly one solution, so we're guaranteed a solution for every input. And we can't use the same element twice. So basically what that means is that if we have an element at index I and we have another element at index j, they cannot be the same. And finally, we can return the answer in any order. So we're returning a list of ij, so we can return either I, j, or j, I. To illustrate this problem more clearly, we can go through a few examples. So for this, we're given the integer array as 2, 7, 11, 15, and the target is 9. So if we apply our algorithm, we want to find two elements in this array such that they add up to 9. Well, it's not too hard to see that the two elements are exactly 2 and 7, because we have the formula 2 plus 7 equals 9. And if we want to write this more generically, we can write A plus B equals targets, where A and B are in nums. Okay? And if we write out the indices above this array, we're actually going to be returning 0, 1, or 1, 0. That's because the index at 2 is 0 and the index at 7 is 1. Now if we go through this second example, it's quite similar. We can see that the only solution is 2 and 4, because 2 plus 4 equals 6. And if we again write out the indices, we're going to see that we have a return of 1, 2, or 2, 1. So hopefully these examples are clear and you get an understanding of what the problem is asking. So if we actually go ahead and try to come up with an algorithm, maybe a brute force algorithm first, we're going to see that we're first tasked with finding the two elements. And if we actually want to find every single element, we're going to have to traverse and keep track of the two elements via pointers. So the way we do this is that we can traverse them using a nested for loop. So let's consider this example again. Well, if we list out all the pairs between two elements, we can see that if I list it out in a particular way, we get all these pairs, namely 6 pairs. And the way I did this was I fixed the I pointer and I incremented the j pointer. And every time the j pointer reaches the end of the array, we simply increment the I pointer and we reset the j pointer to be exactly one more than the I pointer, because the I pointer cannot be equal to the j pointer. So if I write this pair out in pseudocode, we can see that it's simply just a for loop that goes from 0 to n, and we'll say that n is the end of the list, and another for loop, j, which goes from I plus 1 to n, and we're going to check if the elements, so nums of I, plus the nums of j is equal to the target. And if it is, then we can just return I and j. Or we can also return j and I if you'd like. So if we analyze the time complexity for this, we can consider the worst case time complexity, Well, we know that this for loop is going to run exactly n times. And we also know that this for loop is going to run n minus 1 times. So really it's n times n minus 1, which is going to give us a big O time complexity of O of n squared. Really this is a type bound, so we can write this as theta of n squared, but they're practically the same in this context. That being said, we can go ahead and code up a brute force solution in Python. As we discussed, we're going to have to write a for loop from the len of nums, and we can write another for loop, and we said that this is going to start at I plus 1 and go to the end of the list. And our third line was checking if exactly we have this equation a plus b equals target. So we can write nums I plus nums j is equal to target. And if it is, well, we can just return I and j. And you can also return j and I if you'd like. So we can check this code to see if it works and submit it. And we can see it's accepted, but it's not the fastest. Okay, now that we have a brute force solution that's running in O of n squared worst case, can we do better? Well, yes we can. We can actually use a data structure called a hash map. Now, given the same array, 2, 7, 11, 15, we can actually go ahead and insert all of these elements into a hash map. And what's so good about a hash map is that we know that the lookup time is going to be O of 1. And we also know that the inserts is going to be O of 1 on average. So what we can say is that we can populate the hash map with elements from the nums array. Basically what that's going to look like is that we're mapping each element to its index. So this is what the hash map will look like once we populate it via a for loop, because we need to traverse every single element to add it into this hash map. Now, what we can do after is we can simply use the fact that targets minus some element a is going to give us exactly the element. Now, if you don't quite see how we got this formula, we can actually just rewrite it as a plus b equals targets. Now, if you see that these two formulas are exactly the same, so we're just using this fact, and we can actually look up this b element in the hash map. So let me give you a quick walkthrough on how we're going to do this. We already have this hash map initialized. So in our second for loop, we're going to go through 2, 7, 11, 15. So first we're going to look at 2. We know that the target is 9. Minus 2 equals 7. Well, is 7 in the hash map? Yes. So we know that this is exactly the pair that we're going to return. And while we're going through the for loop, we can just return the I and the element that 7 is mapped to, which is the index here, 1. So this is going to be exactly equal to 0, 1. And this is going to just be 2O of n in its worst case, because we know that a for loop has a worst case time complexity of O of n, and we're looping twice, so it's going to be 2. Now there is this slight modification and optimization that you can make to actually get this just to run in n steps. Well, we can just combine these two processes into one while we're adding and traversing the hash map. This will be more clear once we write out the code, which we'll do right now. We can write out a more elegant solution as we discussed. So we can initialize a hash map called D, which stands for dictionary. We can write a for loop, but I'm going to keep track of the index and the element using enumerate. So just to make my life easier, and we're going to enumerate over the integer array nums. We're going to check if the target minus the num, so as we discussed, this is exactly the target minus a equals b formula. If it's in the dictionary, we're just going to return I, which is the current index, and d target minus num. So we're accessing the elements for the pair. And if it's not in the hash map, we can simply add it to the hash map. Okay, and this should be the solution. If we go ahead and write out this solution in LeetCode and submit it, we should see that it is also accepted. And we can see that there is a big time improvement, although this is still not the most accurate. Just for clarity, we can say that this is going to have an O of n complexity in terms of space, because we're using a hash map, and in the worst case, we populate it with every single element, and the pair is the last two elements in the integer array. With that being said, thank you all for watching. Hope you learned something, and hopefully my explanation was clear. And hopefully I'll see you guys soon.